Our project aims to integrate traditional bamboo material with augmented reality and make a house design app for low-cost houses in Chinese rural areas. The design app can automatically generate building spaces, structures, and enclosures based on users' input data. Our target customers are mainly villagers living in southern China, such as Yunnan and Guizhou province. Many ethnic minorities live here and hold activities in their colonies. After the background, we began with bamboo material studies. There are 3 types of bamboo materials. After fabricating, different parts of one raw bamboo can play different roles in a building. We did a series of bending tests of different bamboo materials and tested out some bending angles of bamboo strips. Next, we tested the bending function of some fresh bamboo poles. We also found that bamboo joints can strengthen the structure. After that, we tried to connect multiple bamboo poles or strips and made bending tests and simulations, and we tried to develop bending prototypes. From the material experiments, we extract the original loop features and did some prototype studies. We also attached an enclosure to the main structure. With the help of generative design and AR assembly, people without any design background can design and build their unique houses following some simple steps.
Welcome to Vernacular. Please log in.
On the home page, users can get access to new projects from other people on this design platform, and share information about their bamboo houses.
Select Design Mode. Please scan your construction site. Model loading. Please fill in the form of basic data and room functions.
Our backstage design logic includes 6 steps. The first is to generate space prototypes. Our units are generated from the experimental prototypes to create some organic spaces, and they are based on the scale of different room functions. After that, we receive requests from users. The background system will automatically start generation according to the needs. The frames of all rooms are variants of experimental prototypes. Each room has a different scale, connectivity, and openness. These diagrams show the direction each room can be connected to the other one. And we have many variants of primary spaces. We can assemble different spaces to generate a variety of combinations. By adjusting different openness and connection direction of units, we can get a number of variants. The main structure is composed of 4 basic loops. For the open surface, the main structure is subdivided 4 times in the surface. Through 4 subdivisions, the mesh-like braided structure of the cicada was differentiated. The main structure is connected by loops, which are connected by 2 arch structures, and the arch structures are connected by rib structures extending from the main structure. Finally, the raindrop structure covers the rib structure to support the surface. As for the unit connection, we first explore the changes of the mainframe when 2 units are connected together. Then we explore the connection of surfaces on the basis of the mainframe. And we explore more possibilities of the mainframe combination. Meanwhile, there are more possibilities of the changes of the surface. For the generation of the house, we first generate the living room. Then we generate other rooms around the living room. Users can preview the combined units through an AR camera. If the user is not satisfied with space, he or she can reset them. These bamboo weaving structures enclose the mainframe layer by layer. Each layer has a different weaving density. After the basic shape is generated, users can select the weaving pattern from the model library to use as the pattern for the enclosure. Users can DIY a unique pattern as well. We create a set of 12 × 12 grids, and by tapping the screen, the white grids change into black ones. The keel and waterproof layer cover the surface of the main structure. Users can preview each layer of the building on a real scale, and walk into the building to see the interior. They can also go through the gate to have an tour of the colony.
New message, you can start AR assembly.
After the confirmation of the design, users can either build the houses themselves or hire workers. The fabrication process is assisted by an AR assembly guideline in HoloLens to build step by step. Multiple types of bamboo materials are used for different layers of the building. Users can test the bending properties of each bamboo pole. First, users cut single bamboo poles into needed length. Next, they tie them together into bundles and then connect the ends into loops. We divided the bamboo into 2 layers, inside and outside, and ensured the integrity of bundles through interlocking joints. After that, we connect the ends of bundles to form the inner layer of each loop. Users can strengthen the loop by adding more bamboo poles. For the main structures, users can follow the order in our assembly guideline to add the loops one by one and connect them in the highlighted points. Due to the construction and bamboo material limitations, we could only build a 1:2 scale model using bamboo poles 6 feet long. Users can tap on the buttons to preview each element and joint. After one element has been assembled, they can turn the highlight display off. As the number of loops increases, the structure becomes more stable and can form the shape of a space which can be used for residence. Different types of joints are used for connecting different layers of components. After the main frame of the living room is built, we assemble the structures of the rest of the building and connect them with the living room. Then, we add a secondary structure and enclosure to the main frame following a similar assembly guideline. We use thinner bamboo poles to assemble the secondary structure. In the last section, we will show the generation of a larger scale building. We use local materials and take advantage of the low cost of construction. Nearby bamboo can be cut down during the construction process. With the help of our guidelines, the construction speed will be highly improved. AR applications in architecture are not only the use of high-tech materials and construction technology, but also the use of vernacular material to build in a more traditional way. We hope in the near future, residents in remote areas can use our architectural design and construction system to create a more comfortable living environment for themselves.